All right, last unit or mini unit, it's mini unit because it's shorter than majority of the units, is exponents, and the properties of exponents, the laws of exponents, and scientific notation is all kind of lumped into this unit or this section. This is one of those 8th grade units that's not covered on your 7th grade EOG, but the expectation is that you're going to go to 8th grade, you're going to remember it, and you'll be assessed on it for your 8th grade EOG. The first thing we have to do is get through what the vocabulary is. And so the first part you have to know is the base. And base is the number that is going to be raised to a power. This is your big number. To put it in less mathematical terms, it's the big number. It's the number that you're going to end up multiplying a lot. The other number that we're asked to deal with is, or the other word, excuse me, that you're asked to deal with is the exponent. And the exponent is a number that tells how many times to multiply the base by itself. So the thing that you should know, again, the less mathematical term is it's the small number. And in the case of the exponent and the base, when we see that exponent, we've got to remember that that's not telling us the number to multiply by, it's telling us the number we want to, how many times we want to multiply that base by. So the labeled example would be base is raised to an exponent. The first examples that we're asked to do is to write each expression in exponential form. So let's go through these 4 examples. The first one that we are asked to write is -6, notice it's in the parentheses, times -6 times -6 times -6 times -6. When we write our answer, we want to write our base as it's written. So in this case, that happens to be -6 in parentheses. And then we're asked to see how many times we've written the -6, and there's 5 of them. So the answer would be -6 quantity to the 5th power. For the second one, with all of those x's, we notice that our base is x, because that's the number that's being repeated over and over, and that there's 9 of them, so it's x to the 9th. For the third one, we have our base, which is 8, but notice that 8 is in the denominator. We need to leave it in the denominator. It's not going anywhere, not yet. So we have 1 over 8, and there's 10 of them, so that's 1 over 8 to the 10th. And for the last one, we have 4 over 7, and if we count it up, the 4 is written 8 times, and the 7 is written 5 times, so it would be 4 to the 8th over 7 to the 5th. The reason this is exponential form is because we didn't calculate what the value of it was. All we did was state how many times the base was being multiplied by itself. Okay, moving on to the next page, you'll notice that you have these 3 tables put on this page, in which we have a base of 2, a base of 5, and a base of 10. The hope is that you will realize what happens when these things start, or that you'll be able to pick up on the pattern. So in looking at the first one, 2 to the 4th, we know that means 2 times 2 times 2 times 2, and that happens to be 16. And 2 to the 3rd is 2 times 2 times 2, which is 8. And 2 squared is 4, and 2 to the 1st is 2. If you take a look, to get from 16 to 8, we ended up dividing by 2. And to get from 8 to 4, we divided by 2. And to get from 4 to 2, we divided by 2. So if we're going to continue this pattern of divide by 2, that means 2 to the 0 would have to be 1. 2 divided by 2 is 1. If we continued, notice that these exponents are now negative, but the pattern should still remain. So we now have 1 divided by 2, that's 1/2. And if we kept up the pattern, 2 to the -2 would be 1/4, 2 to the -3 would be 1/8, and 2 to the -4 would be 1/16. Notice what 2 to the +4 exponent was and 2 to the -4 exponent is. Or 2 to the +3 versus 2 to the -3. 2 squared versus 2 to the -2. 2 to the 1st versus 2 to the -1st. That is something that I'm hoping you're able to see to help understand why the rules of exponents are the way they are. Moving on to base 5, we note that 5 to the 4th is 5 times 5 times 5 times 5, which happens to be 625. 5 to the 3rd is 125. 5 squared is 25. 5 to the 1st is 5. Again, notice that to get from 625 to 125, we divided by 5. 125 to 25, divide by 5. 25 to 5, divide by 5. If you think about what you're doing in the inverse of multiplication, when you take away an exponent, that's really just dividing by one extra base. So now that we keep up the pattern, 5 divided by 5, that would equal 1, meaning 5 to the 0 is 1 whole. If we kept up the pattern, we would have 1 divided by 5, which would be 1/5. So 5 to the negative 1 is 1/5. 5 to the negative 2 is 1 over 25. 5 to the negative 3 is 1 over 125. And 5 to the negative 4 is 1 over 625. Again, notice what happens between 5 to the 4th or compared to 5 to the negative 4th, or 5 to the 3rd compared to 5 to the negative 3rd. 5 to the 2nd versus 5 to the negative 2nd, and 5 to the 1st compared to 5 to the negative 1st. The last one we're asked to do is a base of 10. So we have 10 to the 4th, which is 10,000. 10 to the 3rd is 1,000. 10 squared is 100. 10 to the 1st is 10. If we were to take a look at the pattern, 10,000 to 1,000 is dividing by 10. 1,000 to 100 is dividing by 10. 100 to 10 is dividing by 10. And therefore, if we kept up the pattern, 10 divided by 10 would be 1 whole. In moving on into the negative exponents, 1 divided by 10 would be 1/10. And 1/10 divided by 10 would be 1 over 100. 1 over 100 divided by 10 would be 1 over 1,000. And 1 over 1,000 divided by 10 would be 1 over 10,000. Again, take a look at comparing the positive exponent versus its opposite, the negative exponent, and what you end up with for the value of that expression. Now that you've seen it in chart format, this should hopefully make this part a little bit easier. Where it says that for every non-zero number x to the 0, that's always going to be 1. No matter what, anything to the 0 power will be 1 for now and for always. Whenever you have a non-zero number with a negative exponent, it's the same thing as 1 over your base with a positive exponent. So we end up with 1 over x to the a. Because we noticed on the previous chart that whenever we had a negative exponent, it just became a denominator for the positive exponent. Now let's take a look at these examples. The first one, we are asked to find the value of 4 to the 0 power. We know that that is going to be 1 because anything to the 0 power will be 1. For the second one, we have negative 7.8 quantity to the 0 power. We know that's going to be 1 because anything to the 0 power is going to be 1. And for b to the negative 5th power, we know that anything to a negative power is going to be 1 over the base to the positive exponent, so it becomes 1 over b to the 5th. In looking at the second one, we have 6 to the negative 3. We know that's going to be 1 over 6 to the positive 3. And we are asked to simplify these all the way, therefore we have to know that 6 to the positive 3 has a value of 216. So the simplified answer to this question is 1 over 216. 1 over b to the negative 9th. Well, when the negative was up top the way it was on number 3, because we can think of it as b to the negative 5th over 1, we were able to notice that it went down to the bottom of the fraction bar. So if it's on the bottom of the fraction bar, we note that to make it positive, it would need to be above the fraction bar over 1. So 1 over b to the negative 9th is just simply b to the 9th. For number 6, we have 1 over 3 squared. Same idea. We bring it to the top, so it becomes 3 squared. And we know the value of 3 squared is 9. For number 7, we note that a to the third, already positive, there's nothing more to do with it. M to the negative 6th, well, it's in the denominator. We want to make it positive, so we end up bringing it up to the top and we get m to the 6th. For the second one, we have a to the negative third, m to the negative 6th. Well, when a to the negative third was on top, it was negative, so we need to bring it to the bottom and it becomes positive. But we know that for m to the negative 6, we need it to be up top and it becomes positive, so it becomes m over 6 a to the third. And then for the last one, 1 over m to the negative 6 a to the negative 3. In this one, both of them are negative in the bottom. Therefore, when they come up, they become positive, so it becomes m to the 6th a to the third. We need to note that your answer should always have a positive exponent. You never want it to have a negative exponent in the answer. You will be learning the more specifics as to the fraction bar piece to this. However, this is just a general, know that if it's negative, you're going to move it to the other side of the fraction bar. You'll find out why on another video.